Once we've created and selected a Bezier or NURBS curve, the Properties Editor produces a Curves data page, represented by a simple green curve icon. There are several headings in this page, starting with Shape. The first entry here is Dimension, though it is unlabeled. The choices are 2D and 3D. These are effectively radio buttons. Choose one or the other. If we stick with the default 3D, any new curve, which is initially on the XY plane, can have its control points moved in the third, Z direction, making the curve itself stretch through all three dimensions. If we switch to 2D, the curve is restricted to 2 dimensions and remains flat, though it can still be rotated. Next comes Resolution, with Preview U, defining the resolution in the 3D viewport, and Render U, defining the resolution used in the render. This resolution determines the number of points on the curve calculated between each control point. Larger numbers give a greater accuracy but requires more calculations. Setting Render U to 0 makes Blender use the Preview U value in the viewport and also in the render. Twist method. When the curve passes through 3 dimensions, this creates a twisting in the curve. This twisting affects the direction of the curve's normals. There are 3 possible choices when calculating the twist. Minimum is the default, with Z-up and tangent being the other options. Smooth is designed to reduce or remove unnatural twists in a curve when creating hair or fur, and has no effect on other curve types. When we first looked at curves in video 88, we made use of the bevel's depth field to transform the curve into a wire or pipe-like structure. Adjusting this field changes the radius of the pipe. The companion field, Resolution, sets the number of edges around the circumference of the pipe. Back under the Shape heading, Fill Mode determines how much of this pipe's structure is displayed. The options are Full, which is the default, Back, Front, and Half. However, if we've selected the 2D dimension option, the choices in the Fill Mode field change to None, Back, Front, and Both. And to demonstrate these options, we'll create a new 2-dimensional Bezier curve, and using extrusion, handles, and closing the 2 ends, we'll create a figure of 8 shape. We'll also skip ahead and set Extrude in the Geometry section to 0.2 meters. Finally, we can return to Fill Mode and see the effects of each option. Notice that there's a problem when filling over the area enclosed by the curve with a hole in both the front and back areas. The fill algorithm used in 2D's Fill Mode is determined by Fill Solver. Sweep Line is the simplest and quickest method, but cannot handle situations where the curve overlaps itself, as it does in our figure of 8. The second alternative here is Delaunay, which is designed to handle these more complex geometries. And when we switch to this option, we'll see the surface holes disappear. Fill Rule is only available when Fill Solver is set to Delaunay. Again, there are 2 preset options, with even, odd, and non-zero, meant to deal with the surface rendering in different ways. To demonstrate, we'll start by creating a 2D Bezier circle. Then, in Edit mode, we'll create a second circle, reducing it in size. With Fill Mode set to Both and Fill Solver at the default Sweep Line, we get a filled-in ring shape. When we change Fill Solver to Delaunay, Fill Rule produces the same ring when even odd is used, and a filled-in disc shape when non-zero is selected. The last 3 items under the Shape heading are checkboxes that are used in conjunction with the Curve Deform modifier which will be covered in a future video. The next heading is Texture Space, and unsurprisingly, the entries here involve adjusting the texturing of the curved surface and must wait for a future video. Now we come to Geometry, and we'll start in the Bevel subheading since we've already seen the purpose of Depth, which sets the radius of the tube effect added to the curve, and Resolution, which sets the number of points calculated on the circumference of that tube. The Fill Caps checkbox is used to close the two ends of the pipe. However, at the start of the Bevel section, we have three mutually exclusive options. If we change from the default Round to Object, then we can make the pipe cross-section mimic the shape of any other existing curve. For example, if we create a Bezier circle and adjust its shape, then by selecting that shape in the Object field, our pipe takes on a matching cross-section. The third option is Profile. When we select this, we are presented with an adjustable graph-like display where we can drag on the line to create any profile we want for the cross-section. This type of option is used in other commands, and the options it presents were covered in detail in video 45. Going forward, we'll assume our curve has been assigned a circular cross-section. The second subheading is Start and End Mapping. Factor Start and Factor End determine the part of the curve that has the pipe displayed. A start value of 0 represents the start of the curve, and an end value of 1 represents the end of the curve. By adjusting these two values, we can control which part of the curve displays the pipe effect. Let's say we set the factor start to 0.5, so that the tubing effect should start halfway along the curve. Exactly what Blender considers to be halfway is determined by the Mapping Start setting. When this is set to Resolution, Blender takes the 0.5 in Factor Start to mean the middle control point. In our example, we have 3 control points, so piping starts at the second control point. When Mapping Start is set to Segments, Blender starts the piping about halfway along the curve's length, ignoring the number of control points. The trouble with the Segments option is that it makes assumptions about the structure of the piping effect that may not be completely accurate in all cases, particularly when the curve has sharp bends. The final option is Spline, and this uses the mathematics of the curve itself to ensure absolute accuracy of the starting point. Mapping End has the same 3 options for controlling the calculations at the other end of the curve. Jumping back to the top of the Geometry section, we have Offset, which moves the visual effects created, such as piping away from the position of the curve itself. The movement is parallel to the curve's normals. Extrude adds another dimension to the effect already created by extruding the shape. If no effect has previously been added, extrusion creates a two-dimensional sheet-like effect. Taper Control allows us to control the thickness of the curve's piping so that it is no longer uniform along the whole length of the curve. To do this, we need to add a second curve. We'll name the new curve Controller and the original curve Target. With Target selected, we'll choose Controller in the Taper Control field. We can do this from the drop-down list or by using the eyedropper. Now, after reselecting Controller and entering Edit mode, if we select a control point and move it in the Y direction, this adjusts the thickness of the target curve's piping. Y distances in the controller curve are measured relative to its origin. Taper radius determines how the controller curve influences the final result. Override uses the controller curve's characteristics exclusively, ignoring the previously piping thickness of the target curve. Multiply multiplies the controller's effect by the weight setting of each control point on the original curve. Since the default weight is 1, this will have no effect at the moment. We'll see how to adjust the weighting in the next video. Add adds the controller's effect to the existing target thickness. The checkbox Map Taper is only relevant when making use of the Factor Start or Factor End options. When the box is unchecked, adjusting the start and end options of the target curve also reduces which parts of the controller curve are used. When the box is checked, the whole of the controller curve is used on the displayed part of the target curve. Path animation and animation will be covered in the animation series of videos. Shape keys. Without using an add-on option, a curve cannot directly use shape keys and must first be converted to a mesh. Shape keys were covered in video 75. Custom properties allows us to add new features which can control existing parameters, but this is outside the scope of these videos.